So for this first one, to multiply it out, notice we got something outside the parentheses. That means distributive property. So I'm going to multiply this 5x squared into every single term here. For the first one, when I do the 5x squared times 6x to the 8th, I have to do 5 times 6 first.
30.
That's just 30. Then I have to do x squared times x to the 8th. Now when I multiply x's, what do I do with their exponents? We add them. Yep. So that gives me x to the 10th. That's it for that one. And then I go on to the next term. I'll get fancy. I'll color code these. So we're now going to do 5x squared times 4x. So I do the 5 times the 4.
20.
It gives me 20. And then x squared times x. That's going to give me x to the power of what? 3. Yes, because remember that x there is just x to the 1. And so then that is x cubed. Now we do the 5x squared times the 9. Notice it's a minus in front, so it stays a minus. 5 times 9 is 45. Since there's no x in it, it stays in x squared. And we're done with that one. All right, then we're ready to take on the next one, where we're multiplying binomials together. So I'm going to multiply everything in the first parentheses by everything in the second parentheses here. So I start by doing that x times x. Remember, x times x is x squared. Then I do the x times the negative 2. So that's minus 2x. Now I do it by the 7. So 7 multiplies by the x. So that's positive 7x. And 7 multiplies by the negative 2. So that's a negative 14. One last step in this case, though, we can actually combine some like terms. And yes, we need to. The x squared stays in x squared because there's no other x squareds. But the minus 2x plus the 7x, that becomes a positive 5x. And the 14 stays the 14. So that then is your final answer. That's what we're looking for. Yes, we always need to combine the like terms at the end. This now is how we're taking it up a level today. You notice it's no longer just going to be a binomial times a binomial. In this case, it's going to be a trinomial times a binomial. But the good news is it's really the same idea at play. We're still going to multiply everything in the first parentheses by everything in the second parentheses. So let's go ahead and actually start working this one through then. So I'm going to start by doing the x squared times x. Now, just like we saw in that first problem that we did, x squared times x is going to give us x cubed, because of that invisible 1 on our x here. And then I'm going to do the x squared times the minus 3, so that's going to give me minus 3x squared. And I'll continue. I just did the x squared, now I'm going to do the 5x. So I'm going to do 5x times x. That's going to give me 5x squared. Do not forget that it changes our exponent here. And then I need to multiply the 5x by the minus 3. So that's going to be a minus, because a positive times a negative is a negative. 5 times 3 is 15, and yes, there was an x in there. Then we go on to the last one. We've got to now multiply through by the 1. So we're going to do 1 times x. It's going to give me just, of course, 1x, or x. I don't like to write the 1 in. It's not quite as tidy, but you can if you want to. And then I'm going to do the 1 times the minus 3, which is minus 3. We've done the multiplication now. We've done the hard part. But we're not done. We still need to look for any like terms that we can combine. And as I look through this, I see a couple that are x squareds, and I see a couple that are just plain old x's as well. I'll mark those differently. I'll put a box around those, and I'll leave the other ones just underlined. Remember, marking them in different symbols is a great way to keep track of which ones get combined with which on your own paper. All right, so notice the x cubed, it didn't have any friends. It's all on its lonesome, so it stays an x cubed. But after that, the x squareds, I do combine those. I got minus 3x squared, so we treat it like a negative 3, plus 5x squared. Negative 3 plus 5 is a positive 2, so that's plus 2x squared. Notice my exponent didn't change. We only change exponents when we multiply or divide them, not when we add them. That's why they got to be like terms. Then I got the negative 15x plus the x. That's like negative 15 plus 1. So it's negative 14. So I go minus 14x. And then that minus 3, again, it didn't have any others like it, so it stays the minus 3. And it's done. That is your final answer. That's what we're looking for on this one. All right, for this one, you're doing it on your own first, and then let's check to make sure that everything came out right. So I multiply the x by x squared to get an x cubed. X times the minus 7x gives me minus 7x squared. X times the 6 gives me 6x. I repeat the process with the 4 now. So 4 times x squared gives me 4x squared. 4 times the minus 7, negative 28x. And then the 4 times the 6 is a positive 24. No x's on that one. Then go ahead and combine your like terms. And in this case, marking them with different things can be a bigger help because the ones that are like each other are not next to each other. And so, for instance, I put squares or rectangles around my squared terms there. Makes it easier to see that I'm going to do negative 7 plus 4. That's a negative 3. So negative 3x squared. And then I have some x's. I'll go ahead and circle those. 6 minus 28 is going to be a negative 22x. And then the 24, it stays at 24. So that is now your final answer. Next up, now we're going to take a look at what happens if it's not just more terms inside of each parentheses. Go ahead and write down this problem. And in this case, it's not just a matter of multiply everything in the first parenthesis by everything in the second parenthesis, because you'll notice there's actually 3 different components to this particular expression. We have the 5x, and then we have each of the sets of parentheses. And so basically there's 3 different things that I'm multiplying together in this one. So what do you do in that case? Well, let me take you back to like just plain old numbers. What if I gave you 2 times 3 times 4? How would you do that? Well, you'd really just multiply the first 2 together, or actually any of the 2. So like 2 times 3 is 6, and then you'd multiply that by 4, right? Same thing here. So like in that case, yes, it would be 24. We're going to do the same thing in this case as well, where I'm going to just multiply 2 of them together, and then once I've done that, I'll multiply the result by the third piece. Now, just for the sake of being kind of coherent in order and all that stuff, I'm going to multiply the 5x and the x minus 3 first. But it's really an arbitrary choice. You could actually multiply like the parentheses together first if you wanted, or something like that too. So let's go ahead and do that here. I'm going to distribute the 5x to both terms there, and that's all that's happening right now. So that becomes 5x squared minus 15x. All right, now that whole thing, though, is going to replace this section, which means that whole thing is being multiplied by the x minus 8. Now, if I write it like this now, actually, I'll choose a different color just so it differentiates a little bit easier. If I wrote it like that, this would not be okay. Because you'll notice that right now, this is saying that I'm multiplying those together only. This is not saying I'm multiplying the 5x squared in there as well. So when you write it out at this point, you have to put parentheses around that first part, the stuff that you just multiplied out to get. So I multiplied the first 2. Now that I've done that, I can now multiply these 2 sets of parentheses. And of course, from this point, it's just like all the other kinds of problems that you've done and that you've seen. We're going to multiply everything in the first parentheses by everything in the second. So go ahead and finish it out. And so there's our final answer after everything's all multiplied out and all combined and simplified as much as it can go. Pay attention to those signs as well. You don't want to lose track of which one's a negative or anything like that along the way. Now, a couple little detail-y things just to answer possible questions that might be out there. What if we had done it in a different order? What if, instead of starting by multiplying the 5x into the first parenthesis, could I have multiplied the 5x into the second one? Yes, I could have, although that's much less common. What if I wanted to just get those parentheses done and out of the way? Could I multiply those together first and then multiply by the 5x? Yes. You can multiply them in any order, just like with that original example, 2 times 3 times 4. It doesn't matter which ones you multiply first, but you just pick two, multiply them, and then you can multiply by the last one. It's just, as a matter of habit, I tend to just deal with the first two, whatever they happen to be, but it's more a habit thing, keeping organized. So now that you've seen all of those problems we've done so far, you now can actually handle something like this. We have three binomials multiplied all together. Approach it the same way as the last one. Pick two, multiply them, take your result, multiply it by the third, and so on. So when you multiply the first two parentheses out, this is what you'd be looking at. Now, at this point, you do have a choice to make. Do you combine the like terms and then multiply? Or do you multiply and then combine the like terms afterwards? They both have their own pros and cons. I'll tell you, I always like to simplify whenever I can, so I'm going to be simplifying first, combine the like terms, and then I'm going to multiply. But if you want to, you could do it the other way too. So this is what I get after combining those like terms, and then I'm going to multiply everything that's left in the first parentheses by everything in the second parentheses from there.